For this lesson, you're performing congruence transformations. Do you guys remember what a transformation is?
Yes. Will change.
Yeah, it's where you move the figure by a translation, which is just where it moves positions. Reflection, which is where it is reflected across one of the axes, either the y or the x-axis, or a rotation around a point. Remember that?
Yeah.
Okay, so look at example 1. Name the type of transformation demonstrated in each picture. We're naming the type of transformation demonstrated in each picture. For A, what do you notice about, and remember, the blue figure is always your original figure, and the red figure is the new image. So what happens between the blue and the red figure for A? Reflection, be more specific. Reflection across the x-axis or a horizontal line, you could say, either way. Since this one's not specifically on a coordinate plane, you could say across a horizontal line. Okay? For B, what happens? Rotation, and it's specifically about a point. It's around that point. Because remember, some rotations don't hit that point.
Rotation about a P.
Yeah, point P. Okay, and then for C, what happens? Translation. And when it's on a coordinate plane, what do you also need to put on here? How far it moves. So you could say X and Y, the first version, translated to X, the new X, and the new Y.
X1 and Y1
is the new measurement. X1, Y1, X2, Y2. Okay? Make sense? That's old news. We've done that before. All right. Look at guided practice number 1. You have a picture of zebras drinking water. Name the type of transformation shown. Reflection. It's the reflection of the zebras in the water. Okay? Look at the bottom of page 272. We're talking about congruence now. Translations, reflections, and rotations are 3 types of congruence transformations. A congruence transformation changes the position of the figure without changing its size or shape. Okay, so make sure you recognize that. The shape didn't change size or shape, it just moved or rotated or flipped. All right, so top of page 273. Whoa. In a coordinate plane, a translation moves an object a given distance right or left or up or down. You can use the coordinate notation to describe a translation like we just talked about a second ago. So look at key concept. Put this in your journals. It's very important. Okay? If I have a coordinate plane, okay, this is my Y, this is my X line, and I have my first figure, and bear with me, my drawings will not be perfect. Okay, and I have a triangle here, and then it gets translated to up here. Obviously, those triangles are not perfect, but go with me here. Okay, to discuss the coordinate notation, you talk about one point and how it translates X, and then how it translates Y. So this would be A and this would be B. For instance, if I have the measurement XY for my first point on the blue triangle, we would talk about how it translates, and you would say X, the original X, plus how many we went across. Okay, that's the new position. And then Y plus B, or how much we went up. Okay, so I'm going to get a new color here. So for A, we went across here. We're adding it to the original X. And then for B, we measured how far up we went. And then if you were to simplify that X plus A and Y plus B, that gives you your new position for the same point. Comprende? All right. That's important. So let's look at example 2. Put this in your journals. Translate a figure in a coordinate plane. We have figure ABCD, and it tells you the vertices are -4, 3. For B is -2, 4. For C, it's -1, 1. And for D, it's -3, 1. It says to sketch ABCD and its image after the translation. And here's your instructions, basically, for your translation. We're going to add 5 to X and subtract 2 from Y. You're going to do that for every single point to draw your new figure. Make sense? Does that make sense? Diego's like, why do I have to do it for every point, right? That was your instinct? Well, when it's not a perfect square, it's hard to figure out all the points perfectly. So if you translate every point using this equation, then every point will be perfect and you just connect the dots on your plane. So I would do the math first and then I'd sketch both. It's the simpler version. So for A, we're starting with -4, 3, right? So to translate that, I'm going to say -4 plus 5 and 3 minus 2, which would be what? +1. +1. Make sense? So this is my blue triangle. This is my red, or it's not a triangle, it's quadrilateral. This is my red quadrilateral. So for B, here I'll start putting this in this point. My B point was -2, 4. To translate it, we're going to say -2 plus 5 for X and 4 minus 2 for Y, which translates to, what's -2 plus 5? +3. And what's 4 minus 2? So my new point B in the new quadrilateral is at 3, 2. For C, we're using -1, 1. Translates, you say -1 plus 5 for X and 1 minus 2 for Y, which translates to, what's -1 plus 5? And then 1 minus 2? -1. And then my last point, D, original is -3, 1. Translates, you say -3 plus 5 for X, 1 minus 2 for Y. So -3 plus 5 is, and, oops, -1. Okay, so I have my 4 original points for my quadrilateral right here, and then my 4 new points for my new quadrilateral. And you would see a translation. Do you want me to sketch it, or do you guys get how to sketch it? Yeah, you do have to do that in your homework, but I'm pretty sure you guys get it. So, in this lesson, you want to show whether, this one's just a simple translation. There's no reflection. Once you sketch it, you would know if there's a reflection or rotation or any of that stuff after you've sketched it. All right? Okay, so that's a simple translation. Look at the reflections part of this, bottom of page 273. When a reflection is shown in a coordinate plane, the line of reflection is always the X or the Y axis. So it's either going to flip horizontally or flip vertically. Okay, those are your two options. Okay, so look at these. You see reflection across the X axis, your blue original shape compared to the red shape, the second version. You see what they did to find the new points. Okay, look here at the bottom. They took each original point, x, y, and to translate it, they multiplied both x and y by -1. Just the y coordinate. I said that wrong. Because it's translating across the x-axis, you only have to change the y-coordinates. All the x-coordinates should be the same, which makes sense. I'm going to get a bright color here. Okay, this x should be the same as this x. Make sense?
Yes.
This x the same as this, and so on. The only thing that changes is the y. Instead of being in quadrant 1 where all the y's are positive, it's now in quadrant 4 where all the y's are negative.
Yes. Amen.
So to write out that translation, you could say that they do x and then they do y times negative 1, which is just x and a negative y. Does that make sense? Okay, now if it's going across the y coordinate, what do you think they change?
X.
The x is multiplied by a negative 1. Because again, looking across here, my y coordinate shouldn't change across here. It's still the same on the y line. Your x just changed because from quadrant 1, where all the values are positive, it flips over to quadrant 2, where all the x values become negative. So again, my translation here from x to y, translate across, we're going to say negative 1 times x, and then y, which just is negative x, y. Does that help clarify that for your concepts? Turn the page, 274. Example 3. Okay, you are drawing a pattern for a wooden sign. Use the reflection in the x-axis to draw the other half of the pattern. So looking at this, you guys could probably figure out the shape and just sketch it, right? Yes, you guys are smart enough to do that. However, I want you to do the translations. You need to do the work so you get the correct points, not just guess. Because if I could guess, I would just go, okay, 1, 2, 1, 2, 1, 2, and then connect. Okay? Not perfect, but it would work. But all you have to do for your homework is just translate x, y, and here, which way is the reflection across? Across the x, so which coordinate are we going to multiply times negative 1?
Y.
So you're going to have x and then negative y. So if I look at my original points here, I have this point, this point, this point, this point, and this point, right? Do I need to do these two on the x-axis? No, you don't need to do those. We just need to do these far away points. Say, what points would those be? We have negative 1, comma 2. Okay, that we need to translate. We have what? 1, comma 2. We have 1, comma 4. Okay, 5, comma 0, which is this point right here, that doesn't really change because 0 times a negative 1 is 0, right? Okay, which is also why this one's not going to change because 0 times 0 is still 0, or 0 times negative 1 is still 0. So we just need to translate those three. So we're multiplying the second coordinate times a negative 1. So the first coordinate doesn't change, negative 1. 2 times negative 1 would be? So there's that point. This doesn't change. 2 times negative 1 would be? This one doesn't change. 4 times negative 1 would be? So then you have those 3 points, which are your faraway points on the new one, which are going to be here, here, and here. You would plot those points and then connect all your lines. Make sense? Again, a pretty simple assignment. I don't think you'll have any problems with it. Let's look at rotations real quick. Rotation is shown in a coordinate plane. The center of the rotation is the origin, okay, when you have your coordinate plane. Look at the bottom of page 274. Okay, you notice on both of these, they rotate around the origin, and you just have to figure out the angle so you know how much they rotated. This first angle right here is a 90-degree angle, so you say it's a 90 degrees clockwise rotation. Okay, this second angle is a 60 degrees counterclockwise rotation. How do I know between clockwise and counterclockwise?
Blue is where it starts, and then red is where it finishes.
Yeah, here, this is my original one, so it went this direction. This is the original one, so it goes this direction. So pay attention to which way it rotated. This one's not going to rotate all the way around this way. Okay? And you'll notice that on rotations, it preserves the distance from the origin. So from the origin to each beginning point is the exact same distance. So this line equals this line. This line equals this line. Make sense? Okay. All right, so now look at the top of page 275. Example 4, I would probably put this in your journal. Okay, for this, they ask you to, for A, graph segment AB and CD, tell whether CD is a rotation of AB about the origin, and if so, give the angle and direction of the rotation. Okay, so you have A, which is -3, 1. B is -1, 3. Okay, and then they translated to C being 1, 3, and D being 3, 1. So you're going to get a coordinate plane and graph these. When you do that, your original blue should have a segment like this, AB, and then you'll see CD, it's rotated around the origin, and you compare your first 2 points. So I compare A to C. Measure it from the origin, you see that the distance from the origin doesn't change, and then how far did it rotate? It is a 90-degree angle. So which way did it rotate?
90 degrees clockwise.
Yes. So this thing rotated 90 degrees clockwise. Okay, so look at B. They give you the point A being 0, 1, and B 1, 3. C is -1, 1, and D is -3, 2. Again, you're going to sketch these two. Okay, you'll notice your origin is over here on the right compared to your second one. So if this is a rotation, which way is it rotating? Counterclockwise, because it's going to the left. Blue is the original. But let's compare our A and B. A is right here, and it's compared to C. Did it rotate?
No.
It did not keep the same distance from the origin. And then B, compared to D, also does not. So this is not a rotation. It's almost a reflection, but then D's still pushed too far out to the left. So it's just two separate drawings. All right, any questions on anything we've gone over today? Again, I don't think this is a very difficult lesson, so take your time, and you should get it done very quickly. Do numbers 3 through 41 odd. Write that down so you don't forget.